Let's talk about exponents. More specifically, what happens when an exponent is not a whole number? Well, let's start with something simple such as a power we might know, like 2 to the third power. So we should know that 2 to the third power is a shortened way to express repeated multiplication. So 2 to the third power we could write as the product of 3 factors of 2. So we would write 2 times 2 times 2, which is 8, right? 2 times 2 is 4, times 2 is 8. Well, let's continue this by decreasing our exponent. So 2 to the second power would therefore mean 2 factors of 2 multiplied as a product, and that equals 4. And then 2 to the 1 power is a product of only 1 factor of 2, just 2. What happens if we have to talk about 2 to the 0 power? Or 2 to the negative 1 power? And we can continue going it to negative infinity. But there must be something that's happening when we look at exponents when we go lower than 1. So we know that 2 to the third power is a product of 3 2's. We know that 2 to the second power is a product of 2 2's. We know that 2 to the power of 1 is a single 2. But what's happening when we get to 2 to the 0 power or 2 to the negative 1 power and so on? Well, let's take a look at this as a pattern. If I think to myself, well, what's happening as I decrease an exponent just to the products themselves? Well, to get from 8 to 4, didn't we just remove a factor of 2? So you can think of that as dividing by a factor of 2. So this is divided by 2. 8 divided by 2 is 4. And that's literally what it means when you take away that factor. You could divide to remove that factor. Similarly, to get from 4 to 2, you could divide 2 again. So if we see decreasing an exponent as dividing by a factor, we could just continue this process for as long as we'd like. So how would we try to get to 2 to the 0 power from 2 to the 1 power? We would just divide by a factor of 2. So 2 divided by 2 is 1. And this is why you'll see written in many textbooks or online notes or whatever. In general, any non-zero number a, let's say, to the 0 power is equal to 1. And that's what we have just by using the idea of decreasing our exponent is dividing by that factor. Well, let's keep going. If we were to divide 1 by 2, you could write this as a rational expression. This is 1 over 2, right? Division is a fraction in this case here. So 1 over 2 is 1 divided by 2. And you could write that as 0.5. But in general, you might also have seen this in textbooks, if you have a non-zero number, of course. Any non-zero number to the negative 1 power is known as the reciprocal of itself, right? So this would be 1 over a. So there we have another exponent rule just by looking at this pattern here. And continuing on a bit further, let's look at 2 to the negative 2 power and 2 to the negative 3 power. So 2 to the negative 2 power, we would divide by 2 again. Now, 1/2 divided by 2 is known as a fourth. So we're repeating the division, but what happens is that factor actually is a product in the denominator now. So instead of thinking of it as, 2 to the second power, it's actually 1 divided by 2 to the second power, because now I'm dividing by 2 factors. This would be equivalent to 1 over 2 factors of 2, 2 squared. And similarly, if we continue dividing by 2, what we're doing is we're increasing the number of factors that we're dividing by. So this would be 1 over 2 to the third power. And lastly, we can write another exponent rule that you may have seen in textbooks or from your teacher or wherever. In general, if you have a non-zero number a, and it's to the negative m power, let's say, we could write this as 1 over a to the m power. It's the reciprocal power. So that's what we mean by a zero exponent. Any non-zero number to the zero exponent is just 1. Any non-zero number to the negative 1 power is the reciprocal of itself. And any non-zero number a to the negative exponent is the reciprocal of that same power. I hope that helps you with exponents.